Now let's talk about this tetrahedron again. And here you remember that there is a carbon molecule, and here you can add many different molecules. Here you can have another carbon, for example. Yeah. Here you can add another carbon, oxygen, hydrogen, nitrogen, and here, for example, if you have a carbon, here you can have again three more covalent bonds free, and here you can have another one. So every time that you have a carbon, you can have the chance of creating four covalent bonds, and this create a huge diversity of molecules. So sorry for being so repetitive, but this is the key of carbon molecules, because as they have, first thing that you need to remember, they have four valence electrons. They can form four covalent bonds, and it's not only, as I show you, with carbon, but with a variety of elements. In this case, I show you hydrogen, nitrogen, and oxygen. And these allow them to make large and complex molecules. So here we went from a tetrahedron, and here we create, again, you can create another tetrahedron here. Let's put it in green. And another tetrahedron joined together. So you create much and much complex molecules if you want. And so this is the second thing. And the third thing that is important to remember is that in molecules with multiple carbons, each carbon bonded to four other atoms that has a tetrahedral shape. So as I show here, here you can make it more complex and create more carbons that will have again a tetrahedral shape. So now let's see an example of this diversity. And one example of this diversity is isomers. What are isomers? And to explain that, I want that you stop the video and you try to draw this molecule. How do you think that this molecule will look? It's 5 carbons and 12 hydrogen. So stop the video and think about it. Okay, if you draw this molecule, maybe you found this. You maybe draw these 5 carbons and the 12 hydrogens like this. However, you can also have this option. 4 like this and 1 like this. So you just create a small branch. And if you see, both have the same number of carbons and the same number of hydrogen. However, they have very different shapes. And if you draw them in 3 dimensions, you will notice that as they have different shapes, they will have different chemical properties. So another important property of carbon molecules is that they can form isomers, and those isomers, although they will have the same number of atoms, they will have different chemical properties. So first thing that I want that you remember from this slide, I just tell you that isomers are compounds with the same molecular formula, but they have different structures, and as a result, they have different chemical properties. Second thing that I want to show you is that there are different types of isomers. So these, for example, are called structural isomers. And then we will move to other ones. So A, B, cis and trans isomers, and later we will move to enantiomers. So let's start talking about structural isomers. In the case of structural isomers, they have different covalent arrangement of their atoms. So they have similar chemical formula, molecular formula, but the covalent arrangement of their atoms are different. Now let's talk about the cis and trans isomers. And different from the structural isomers, you generally are going to have these two covalent bonds here. And here you're going to have this X, that is a symbol that represents a chemical compound. But in the cis, these two X are on the same side. However, in the trans, you're going to have the two chemicals, the two X, in opposite sides. So as a result, the cis trans isomer have the same covalent bonds. Look, same one, but they differ in the spatial arrangement. While these one are in one side, the 2x, the symbol, here they are in opposite sides. So imagine how the chemical structures will look in 3 dimensions. So for example, if these two are trying to repel each other, it will be very different if they are repelling here and here. So this create a different shape again, and it will have different chemical properties. Now let's move to the last one. Now let's talk about enantiomers, and this is a good example that you watch in your video. The mirror image that are the hands. This is an example of objects that, although they look very similar, they have a different structure. And the same thing happened with chemical structures. Here you have these two molecules that look very similar, but they are very different. And one of the difference, for example, is that they rotate light in a different way, and I will show you that in a second. And another chemical properties that are different, for example, could be, and we have found multiple examples of that. Some of them, for example, when we use medication, if you use one enantiomer, this could be good for your health, and the other one could create side effects, and it could almost kill you. And or the opposite, this could be good and this could be bad. So this is something that we have to check very well, and we will talk about in a second. So thing that I want that you remember, that enantiomers are a group of isomers that are mirror images of each other, and a chemical property is that they rotate light differently. Now we will talk about isomers, but in terms of health, human health. And to do that, I want that you observe this table. In this table, you can see 3 columns. One that talks about the drug, the second one that it will talk about the condition, and here in this third and fourth, you have the effect on human health. And there are a few things that I want that you see here. Maybe you have heard about ibuprofen, very good to reduce pain and inflammation. However, one enantiomer is effective against pain and inflammation, while the other one is not. And if you see the second case is another example. In this case, this medication is good to reduce the asthma attacks. However, here the R is the one that is effective, while the S is the one that is ineffective. So a thing that I wanted you to remember is that the human body has this incredible ability to be sensitive to even small changes. And again, enantiomers are important for the pharmaceutical industry. Second thing that we saw in using this table is that enantiomers may have different effects, such as like what happened here with these two medications. And another thing that we talk about is that they usually only one isomer is biological active. It doesn't depend on if it's an S enantiomer or it's an R enantiomer. And finally, the fourth thing that I want that you remember from here is that the enantiomers demonstrate that living organisms, they are very sensitive to even subtle variation to molecules. So what I wanted that you see is that in the fourth one is that different effects of enantiomers demonstrate that living organisms are sensitive to even subtle variation to molecules. And this is very important when we design medication. Another chemical property of isomer that I talked in previous slides is that enantiomers can rotate light in a different way. While R rotate light in a clockwise direction, The S configuration of enantiomers can rotate light in a counterclockwise. So again, another property of the enantiomer is that they rotate light in different ways. Now let me show you another example of an enantiomer that is very famous in TV. Maybe if I show you this, you will not recognize it. But this one, if you watch maybe this old TV show called Breaking Bad, this is a common stimulant called methamphetamine that is a potent stimulant. However, the mirror image of that is a medication and prevent cardiovascular diseases. So again, an example of one enantiomer that have one application while the other one have a completely different application. And if you watch Breaking Bad, this might be funny. If not, please watch Breaking Bad later.